Alright, come, let us start our lesson. Okay, so the recording is on already. Okay, hi Abigail. Keiko is here with me. It's a one-to-one essentially. Okay, but just pay attention and any questions that you have, alright, you can arrange a consultation with me. I send the sheet into the group, right? Okay, so you can book a consult and then you can ask me there. Okay, for today we are going to spend the rest of the lesson just finishing up this worksheet. Okay, I hope you have it with you as we start this lesson, yeah? If not, just pause the video and go and take it. Simple. Okay, come, let's go. Question 8. Okay, uniform meter rule of weight 0.54 newtons, pivoted at 0 cm, kept horizontal by a string attached at 75 cm. Where is my tension? How to get the tension? I agree. Okay, so because this is a meter rule, right? Okay, then your weight, it's a uniform meter rule. So your weight acts at the center. Acts at middle or center. Okay, and it's just going to go down here, 0.54 newtons. Okay, then this one, is it your tension? Is it clockwise or anti-clockwise? I agree. Okay, it is clockwise. Well, this guy will make the fella go anti-clockwise. Okay, but the fact that this fella is kept horizontal, as the question mentions, means the fella is in equilibrium. So your ACW and your CW will be equal to each other. ACW is equivalent to your red one for your clockwise moment. And then from this point, it's just math. Okay, moment is force times distance, it's 50 cm. So I have 0.54 times 0.5 meters. Yeah. Okay, and then my clockwise moment will be tension, unknown, times 0.75 meters. And then we calculate tension. What's your answer? 0.36. I agree. Very good. Is what the students in the other class got as well. Okay. Let's carry on with question 9. Pivoted uniform bar is in equilibrium under the action of the forces. What is the magnitude of force F? So down here, okay, you realize that these two are in the same direction. I mean, one is up, one is down, but they are causing the same rotation. Okay, they are both going like this. Okay, then your red one will be the only guy. It's a 1 versus 2 situation, correct? Okay, so in a 1v2 situation, no choice lah, you're just going to add it up only. Okay, so I have F times 1 is equal to the sum of the other two. I have 20 newtons acting 4 meters away, and I have 10 newtons acting another 4 meters away. Yeah? Okay, your pivot is very clear lah. Okay, it will be the center of your little seesaw thing. Okay, and when you calculate F, you get, I believe it's 120 newtons. Where did you go wrong?
I thought like the forces have to be equal. So like F plus 10 equals 20.
Okay. So if you have forces that are equal, right, you must then consider the force that this guy is exerting. But that's impossible, right? How to know? We don't know, man. So we cannot use that method here. Okay, but there will be questions where we can use that method. Okay, but then there will be like, like the strings and shit. Okay, then you can measure the tension in those strings. Okay? Next, question 10. Okay, a beam of length 40 cm, pivoted at one end. Okay, you have weight, 5 newtons acting 20 cm away. Correct? Right in the center. Okay, and you have 10 newtons, hangs 10 cm from the balance. So this is 0.1 meter. Then I now have an additional force G, who I'm going to use to keep it balanced. Well, obviously G must act upwards, right? Okay, because the other two forces already acting downwards, you must be upwards. Next thing. Okay, magnitude-wise, it's just going to be a calculation problem again. Okay, I have force G acting 40 cm away, aka 0.4 meters. And then your clockwise moment will be, what I never do? Got do? Go. Okay, what's your clockwise moment then?
Sorry.
What's the clockwise moment?
Is it not blue pivot?
Yeah? Yeah, that's it. How to calculate?
I calculated like the 5 units times the 20 centimeters, so 0.5.
5 times 0.2, yep. And
And also the 10 Newton times
0.1.
Oh, yeah, 0.1.
Yes. Okay, and then you get G equals to, I believe it's 5. It's a nice number here, right? Excellente. Good. Answer is 8. Question? Problem. Okay, very good. I will do question 11. And then you will do a couple of questions by yourself. Yeah? Come, let's go. The seesaw is balanced when the girl sits 0.86 meters to the left. Okay, the boy is 1.1 meters. Okay, right now you just look, right? If girl can sit closer, means girl is heavier or lighter.
Heavier.
Good. Okay, because, was that a guess?
No.
Because if my distance can decrease, means my F can increase, so the girl weighs more. Make sense? Okay. Alright, anyway, so the girl 550, okay, the boy 1.1, 0.86, the fella is balanced, so you can just take ACW equals to CW, right? Your anti-clockwise, is it by the girl or by the brother? Okay, sometimes it takes a while to visualize, I understand that. Okay, anti-clockwise is going this way, yeah? So I have weight of the girl, which is 550, times a distance of 0.86 meters. And then your clockwise is, I don't know what the fellow's weight is, but it's acting 1.1 meters away. And then you calculate your weight, and you'll get your answer. Please go ahead. Okay. Chill. How? What? Okay. Feel free to use your phone calculator, madam.
Okay.
430 newtons. I agree. What's his mass?
43 kg.
Good. Okay, so just a side note, yeah. Okay, his mass is 43 kg. Okay, it's 430 divided by 10. Okay, the girl and the brother slide by equal distances, but the seesaw tilts anti-clockwise. Okay, so now both of them are going to move away. Okay, so this one gonna move a little bit away, this one gonna move a little bit away. Okay, provided it doesn't fall off lah. Okay, so they both move an equal distance. Why is it that it tilts anti-clockwise? So what if she's exerting a bigger force? That doesn't explain rotation.
Is there something to do with gravity?
No? Right now it's balanced, right? It's very nicely balanced, right? But imagine if they both shift like 30 cm to either side. Does it balance the same way? Does the math add up that way? The math should not add up in this manner because it wouldn't be right to calculate it like this. Okay? I cannot just say like, oh, because at this point it's balanced, so if both sides move equal distance, it will still remain balanced. The math doesn't add up. We can just test it out. Okay, so let's say, okay, right now you have 0.86, right? Okay, let's say you shift 0.5 meters. Okay? What will it become? 1.36. So what's your anti-clockwise moment now? It's FF0 times, which is? 748. Okay, now the other side, this fella is also going to shift by 0.5. It will become 1.6. Correct? Okay, so his moment is get it? Okay. So just because I shift the same distance does not imply that the moment will be equal lah. That's the point we're trying to get at. Okay, but how to explain this in words? You cannot use numbers ma. Okay, so we have to say okay, when they so because of them shifting at equal distances, right? Okay, the resultant moment is anti-clockwise, or there is a resultant anti-clockwise moment because the anti-clockwise moment by the girl exerted by the girl is greater than the what? No, the boy doesn't exert anti-clockwise. So the anti-clockwise by the girl is greater than the what of the boy? The clockwise moment of the boy. Because one anti-clockwise and one clockwise, right? But anti-clockwise is bigger, so the resultant is an anti-clockwise shift. Okay? Greater than the clockwise moment of the boy. That's it. This is how you will answer an exam as well, for your WA. You see next week? Better focus up. You got any question, you let me know. Okay? It's just moments, right? What else? Okay lah. Kinematics, dynamics, easy man. Okay, come. Do try question 12 by yourself. Question 12, the behind also have. It's 2 pages worth of questions. Go ahead. What do you not? My 3 Newton weight about the okay, if I tell you about the string, where's your pivot? Agree. You have force of 3 newtons. Do you have distance? No. No. No, look. The string is your pivot, right? So your 3 Newton weight is acting at 10 cm mark, right? While your string is at 40 cm.
So 30.
The distance between them, isn't it? Yeah. So how to calculate moment?
3 times 0.3.
Yeah. Very difficult, man. You have force already, but then you have the distance, Yeah. Go. Is he uniform?
Yes.
So where does his weight act?
The middle.
Yeah. What's the middle of a meter rule?
60.
Yes. Mm-hmm. Madam, okay, your weight is over here, right? Okay, your weight is an unknown value, but you know that he's acting at the 50 cm mark. What's the distance between him and the pivot then? 0.1 meters, right? Then now here's 0.3 meters. I assume you calculated this just now? 3 times 0.3 gets 0.9 Newton meter, right? Okay, 3 times 0.3. Okay, then the fella is kept balanced, ma. This weight, do you think it exerts a clockwise or anti-clockwise? Then your weight, eh? What is going on, mate? Do you need a coffee? Are you very sleepy? Got answer? Got answer already? What's the answer? Huh?
9?
Oh, good. I'm just kidding, man. Carry on. Magnitude is the number. Like what's the value of the force?
Yes, magnitude. I don't need to write the unit.
No, you need to write a unit. But okay, like force is a vector quantity, right?
Yeah.
So you have magnitude and you have direction, right? But if I just ask for magnitude, then you don't have to tell me, oh, it's F acting downwards or whatever. Yeah.
Wait, is that true also?
F cannot possibly be 3 also. Let me tell you why. It makes sense because equal distance, right?
Yeah.
40, 40, but you have weight. I know, you got weight, man.
Yeah. The weight is same as before, right?
I mean, did you change the rod?
No.
Is it made of metal now? Alright. So your weight will be the same, mate.
So is it like F times
Times how much?
0.4?
Yes. You know you're actually quite good. You don't have to be like nervous about it. Just say your answers are all, like pretty much all correct anyway. So you can just like times 0.4. I'm like, yes, brother. Okay, don't worry. Once you calculate finish already, let me know, okay? Then I go through. Once you calculate finish already, you let me know, then I go through.
Okay.
Okay. Okay, so firstly this one, okay, you have ACW equals CW. Okay, so you have your anti-clockwise moment by weights. Sorry, anti-clockwise moment by the tree, right? So it's 0.9 Newton meter calculated before. You have weight times 0.1. So your weights is equivalent to 9 newtons. Yeah. Can I put 9 newtons here?
Yes.
No.
Why?
9.0 newtons. You know about your SF rule, yeah? Better remember, huh? Okay? Otherwise you'll lose a lot of marks on. For no reason, you got the freaking correct answer. But you're minus. A bit bobo, right? Yes, yes. Okay. Explain why force F is necessary to keep the meter rule balanced. You gotta shift the fella, of course the anti-clockwise moment will increase. Agreed?
Yeah.
So you have to mention that lah. Okay, so when the 3 Newton weight is shifted, when the 3 Newton weight is shifted, don't need to copy unless you are blatantly wrong, because you may have used a different phrasing, but your answer may be still correct.
Why is it like so it doesn't go either clockwise or anti-clockwise?
Okay. But the way I'm explaining it, right? Okay, we'll just bring in the moment of the force. you said that so that it doesn't go anti-clockwise or clockwise, you have to tell me previously it was already balanced, right now. It's already not going clockwise or anti-clockwise. So why now that I shift it, I need to add additional force? Okay, so here's how I'll answer. Okay, when the 3 Newton weight is shifted to the 0 cm up, okay, it exerts a greater anti-clockwise moment than before. Agree? Okay. Hence, F is required, okay, to increase the clockwise moment to maintain equilibrium. Or maintain balance. Okay, so maybe you would get the second mark. Right, so that it stays like this. Okay, but tell me, why do I need it? Can? Okay, so down here 1 mark, ending 1 mark. Okay, calculate the magnitude of F required to keep the ruler balanced. Okay, so now I got 3 Newton. On this side, I have 3 Newton times 0.4 now, not 0.3. Yeah? Okay, then on this side, I still have my weight. Okay, and my weight is still 9 Newtons. 9 Newtons is still acting 0.1 meters away. Correct? No? Then you have your new F, that is 0.4 meters. So you have 3 times 0.4, left side equals to right side. I have 9 Newtons times 0.1 plus F times 0.4. I believe F should be 0.75. You get 0.75? What?
No,
Is there a calculation error on my part? Yeah.
No. Mine was F times 0.4 equals 3.0.4 plus 9 times 0.1.
Madam, this one is against him and him.
Oh.
F is not challenging weight. F and weight are the same thing. They are both trying to keep it clockwise.
Okay, I get it.
Brother, what you doing, brother? Okay, wait. So you calculate F first. Okay, F we calculate it as 0.75 newtons. Yeah. If you don't want to check, okay, go ahead and use your calculator and try and find out whether it is actually 0.75. Finish? Okay, tell me, this tension exerts a force upwards, right? What's the tension in the string?
G times 0.4.
You don't need multiplication.
Oh. 12.75.
Very good. Okay, so Keiko is whispering to me for some strange reason, so I will repeat her answer in a volume that Abigail you can hear as well. This tension is 12.75 newtons. Because the meter rule is not moving, right? So F up must equal to F down. What's the downward forces here? I got 3 plus 9 plus 0.75. all of these three are going against tension. Yes? Good. If we are okay, can you do 13, 14, 15, 16, 17, 18, 19? 6 MCQs, you should take about 10 to 12 minutes. Should. In fact, it should be faster than that, but we will practice. Were you trying? Okay, you know what? No judgments, man. Just go in.
And the elbows have pivot. So then it's 0.5.
No, it's 0.05.
0.5. Yeah.
Times.
We don't know the 4.
Correct.
Plus
Plus.
equals.
Okay, so what I'm seeing from you is a pretty important mistake. Okay, you need to know, if I identify your pivot, what are the moments that are exerted around it. Okay, tension acts this way. What moment do you think it has? Clockwise, anti-clockwise, what? This is anti-clockwise. But is there any other anti-clockwise moment? Your load acts this way, isn't it? So then why would you plus anything? It is red versus blue already ma, at this point. Yeah. Yeah. Do you have an answer? Good.
I don't understand how this is working.
Okay. Let me write the working for this one first, in case Abigail did not get it. Okay, red versus blue. So tension times 5 cm is 0.05 meters. And then you have 40 newtons acting 0.35 away. Okay, then you calculate tension from here. Our answer is 280 newtons. Okay, then you have an L-shaped lever arm pivoted at P. What's the overall moment? Okay, firstly, if there is an overall moment, is it balanced? Agreed. Okay, unless you see an option for 0 Newton meter here lah. Right? Okay, but there isn't. So obviously, this fella will rotate. This is a snapshot, but actually it's moving. Correct? Okay, your point is to find out how is it moving. So this is your pivot, right? This 5 newtons, is it clockwise or anti-clockwise? Agreed. Okay, can you see that he is acting this way? Right? Okay, is there any other anti-clockwise moments? Look properly,
The one pivot is exerting.
Huh? What, like there's a force here?
Yeah.
Huh? No? I never drew anything on. No, there's nothing here.
Um,
Picture it happening. If you need to, use your pencil and draw the arrows. All these curve things that I keep drawing.
um, the wave. Actually, no.
Try again.
I don't think there is.
Okay, then in that case, and are there any clockwise moments?
Yeah.
Which one?
20
Okay, so 20 newtons does exert clockwise. Goes like this. Right? Isn't there one force that we're not talking about?
The wave.
Huh?
The wave.
No! Look!
The middle.
The 10 newtons!
But you asked me if it was anti-clockwise or clockwise. That's not going anti-clockwise or clockwise.
Are you sure?
Isn't it going left or right?
Left, up or down? Left or right doesn't mean cannot exert moment. Huh? Okay, visualize this. I have a hanging bar. I exert the force like this. This is the pivot. Is it clockwise or anti-clockwise? There's something hanging, right? I pull this way. Clockwise or anti-clockwise?
Clockwise.
Clockwise, right? So, in other words, the direction of the force doesn't matter. The direction of the force does not mean that you are not clockwise or anti-clockwise. As long as I have a perpendicular distance, I will exert a moment.
Okay.
So the question is, your 10 newtons is clock or anti-clock? Agreed. He is also anti-clockwise. Can you see it's a 2 versus 1 situation now?
Yeah.
Okay? But I want overall moment. Means there has to be a resultant. You get what I'm trying to say? Okay? So, resultant, okay, will be how much?
Resultant force or something.
Why would I worry about resultant force here? The question is asking moment, what?
20
20?
times 3
Mm-hmm.
plus.
Plus.
Yeah.
Your clockwise and anti-clockwise acting in different directions now.
Oh. Oh.
Right or not? Like, they're not helping each other now, they're going against each other. So you have to minus.
Minus 5 times 2.
Minus 5 times 2. Okay, this is 2 meters. Then
Minus 10 times 4.
why 4?
Oh, no, 10 times 2.
10 times 2. Okay, important thing to not make mistake for. Your 10 newtons is acting 2 meters from your pivot. Okay, it's always perpendicular distance, not like horizontal or whatever distance. Okay, I had a student in the other class give me, wow, Nick, I calculate like that. I tell you, Pythagoras theorem is it? You use Pythagoras theorem to solve, okay? That's not perpendicular anymore. Okay? Okay, so minus 10 times 2. That's your, whatever is left behind is your answer. I believe it's 40, but I may be wrong. No, I'm definitely wrong.
30.
It's 30 Newton meter. Good. What's the lesson that we learn? What lesson do we learn? Number 1, doesn't mean horizontal means no moment. Number 2, if you are acting in different direction, you will
Go against them.
go against each other, you will minus each other if you want the overall or the resultant moment. Comprende? Okay. Continue. 15, 16, 17, 18, 19. A lot of questions. Let's go. Abigail, I hope you're getting this. Okay, if not, like I said, okay, either book a consult or just text me on WhatsApp. Okay.
Wait, is it the weight of the group can be ignored, so we don't need to account for the first certificate exists?
I absolutely agree.
Okay.
Yep. Continue. What's wrong with this? Isn't it almost the same thing as just now? Why?
It's just different.
Where will you set yourself different?
I don't know.
Okay, let's set this as the elbow. Okay, then that means I ignore F, right?
Yeah.
Okay, but that means I can find tension, lah.
Yeah.
Okay, so do that, lah. Find tension first. You have these two forces going in opposites.
So tension is 0.05 T equals to 0.9T times 25
Mm-hmm.
plus 0.3 times 40. 0.35.
Yes. Did you find tangent?
Yeah.
Okay. What was the point of you finding tangent then?
Step down.
You already know the answer. What were you finding? But
I was like 37.5.
this one is 37.5.
Yeah.
No, you can't. There's a calculation error somewhere.
What are you doing? Oh, 0.0.
Madam. Blur blur. What's your value for tangent?
375.
So what's F?
310.
Okay. Fair enough. I will do it a different way. You'll see later.
Okay. It says the total mass, so it's like the total weight.
Yeah. Total mass is 60 kg, so total weight is?
600.
Yeah.
But is that useful?
What is? Of course it's useful in this question, in this case. I have to figure out what F I need.
What?
I have to figure out what force F I need to lift it up, right?
So F weight is 600 units.
Yes, the weight is 600 newtons, correct. F is not 600 newtons.
Wait, was the arrow going down? So that's 600 units, or is it not?
Yes.
Why are you easy?
Use algebra. Yes, use algebra.
Okay, I know it is.
Okay. So your 100 newtons X somewhere in between those two forces, I don't know where, right? A certain X meters away. Correct?
I guess so. Yeah.
Okay. Then can you tell me where would you set your pivot to be?
Center.
Set your pivot at the center of gravity.
Yeah.
That's fine. Then you will have two, then you have your 80 one side, 20 one side, right?
Yeah.
Then one side is X, right? The other side will be
100 minus 6.
distance. When X is the distance one. So if X is, okay. So you just look at it, Your 100 newtons is acting a certain x distance away from your 80 newton scale, right? Then your 20 newtons is somewhere here. What's this?
X is the whole thing.
X cannot be the whole thing. Okay, no. So you are saying that you want to let your center of gravity, okay, be somewhere about here, okay, where this distance is x, correct? Then you said you want him to be the pivot, which is fine. Then you have to calculate the distances on both sides, ma.
0.35 minus X.
Yeah.
So that's 18x equals 20 times 0.85. Really?
You said 20 times 0.35 minus x, right?
Yeah.
Yeah. What's 0.2?
No?
What's 0.2?
Wait, 35 minus 7?
Oh.
0.28.
Why are you interested in that? You are trying to find the distance, what?
Uh-huh.
You're trying to find the distance away from the left spring balance, right?
Yeah.
Did you find it already?
No.
You did.
Why did it?
Distance away from your left spring balance is
Wait,
this.
why not? Is it from the center of gravity? So
This is the center of gravity. You said it's a pivot.
So it's not.
Not the left side of the
this
fish.
hole here.
This. The left spring
Oh.
balance, not the fish's mouth.
Okay.
Last question. Done?
Yeah.
Okay, good. Come. Let's go. Okay, Abigail, I hope you are listening as well. Okay, here are our answers. If you don't want to hear yet, or you're not done, okay, just pause the video. A. Question 16 is C. 17 is C, I believe. 18 is A for apple. 19 is D for dog. Okay, everything except the last one. Okay. Chill. Yeah.
17. Why is it?
17. Why is it C? Okay. Yeah, it's definitely C. Okay, wait. I got you first. Okay, come. Okay, so this fella is balanced, which means ACW equals to CW, right? Okay, CW is by Q, ACW is by P. Correct about that? Okay. Then you have force of P. I don't know what P is, times 0.3. And you have force of Q. Again, I don't know what Q is, times 0.7. Right? So your force of P divided by force of Q, we just shifted him over, and then we are going to shift your 0.3 over, is equal to 0.7 over 0.3, or 7 over 3. So find the one that the ratio fits 7 over 3. Okay? Good. Did you guess this or do you do one?
I use what?
You used elimination.
Like it's like since the distance in D is shorter, so the force is bigger, so C and D is definitely not that answer. And like 30 times 30 is 900, 70 times 10 is 700. So that's not the answer either.
Okay, fine, that's fair. Okay, for question 16, okay, I believe you listened to Keiko's explanation just now, but I will use an easier method, one that does not require him at all. In other words, I will make my here will be my pivot. A pivot can be anywhere, right? Okay, I'll make him the pivot. And then you realize, oh sheesh, the F force is acting 5 cm away. Right now? Okay, then he is one person. You look at it as a whole beam, right? Your force F is fighting him and him at the same time.
But aren't they both going down?
Yeah, but I'm not measuring force now, I'm measuring moment. If this is your pivot, force F exert what kind of moment?
Anti-clockwise.
Agree. But the other two is clockwise, right?
Oh.
So it's a 1v2 situation again. Okay?
Wow.
Okay. I don't have to worry about tension, right? Okay, I can completely ignore him. But bear in mind, it won't be 19 cm then. I shifted my pivot, right? 0.14. 40 times 0.3. Okay, and then we calculate F. Okay, your pivot, being balanced means your pivot can be anywhere. I can even set my pivot here or here. Then I can ignore the 40 or I can ignore the 25. Okay, question 17. You ask why is it C? Well, brother, your weight is 600.
Yeah.
Correct? He is acting 70 cm away. Correct?
Yeah.
The other fella is F. Don't know what F is. He is acting 120 cm away.
Not Tuesday.
Madam, this is your pivot. Okay, so you have 600 acting 0.7 meters away, and you have an unknown F acting 120 meters, 1.2 meters away. Solve it. I meant to use your calculator, but yeah, sure. Okay, so for question 18, okay, what we did is, yes indeed, okay, center of gravity is somewhere, but I wouldn't put him as my pivot, because I don't want to deal with multiple forces. You have 80 and 20, right?
So the pivot's at
You can set it, that's fine as well. Your answer, you got it correct, right? So it's okay. Either method, it works. I'll just use this as 100 newtons, because they told me it's a 100 Newton fish. Right? Yeah. Okay, my pivot, I'll set here. This is pivot. Okay, then you just have 100 x
equals.
Stop making that mistake, not the first time. 0.35. Find x. Stop it. Okay, it's not that difficult, right? You freaking got the correct answer. If you careless, I'll be very sad in your WA. Question 19 answer? What do you get? Okay. Firstly, around any circular object, where's your pivot? Or where will your pivot be? Agree. Next, your 250 Newton, do they exert any resultant moment? No, right? Okay, this guy will be anti-clockwise, this fellow will be clockwise. But the distance is the same and the force is the same, because the distance is the radius, Agree or not? Okay, so there's no anti-clockwise moment. Is there a resultant force? You have 100 newtons acting upwards, correct or not? So I confirm got resultant force. Okay? But look at my 25s. Like this. And yeah, like this. So I have a resultant moment as well. I have a resultant clockwise moment. Let me just write it down. Resultant clockwise moment. Yes?
Yes.
Good. Okay lah, come. Do you need a break? Do you need a break? Yes, no? Fine. Give yourself a short break. Abigail, if you're watching the video, okay, I'm just going to list the break in real time. I won't like make any cuts or anything. Okay, I'll give Keiko 30 seconds. No, I'm just kidding. 5 minutes. Okay, a 5-minute break. You want to go toilet or whatever, so you can. Which part of Indonesia do you stay in? Which part of Indo do you stay in? Do you think your house is on Google Maps?
I just moved
Oh, okay. What's it called?
the neighborhood.
I'm just curious. I'm not going to go there. I have no intention to go. Damn! This is your house? It's huge. Oh, but then again, you have a lot of space there, right?
Sorry?
You have a lot of space there, right?
Yeah.
Yeah. Wow, okay. Cool. Then after O's, are you going back or are you going to stay here?
Oh, no.
Yeah.
Of course I'm
I
going.
don't know, I say like, will we be like
Oh.
continuing studies here or
After O's?
like for like either like JC slash whatever?
Yeah.
Good, good. You know my student, that I have this student from India that her father said that if she don't go to JC, if she cannot make it to JC, right? He'll send her to India, then he'll do like arranged marriage. Yeah, then I'm like, what? I don't know. Huh? What school is he going? I will not review that because this video is going to be sent publicly. But yeah, it's weird. It's weird.
My sister's friend is also like that. Okay, no, I don't think she's from Nepal, but then I don't know, I think her dad's like citizenship was like they ran out, so then she has to go back to Nepal.
Oh damn. Like halfway through school.
No, like at the end of Singapore.
Okay. Yeah, I mean at least you have the O-level certificate, right? Then you can use that in wherever you are from. The O-level certificate is quite meaningful. I mean, it means quite a bit, man. So, why you go JC? I'm just curious.
I don't really know what how poly works.
It's just like studies, but more projects and more like work experience. Yeah.
And like most scholars don't go to IIT. I'm sorry, poly. Like they only go to poly if they get like a really bad O-level score.
Yeah.
Or
But will you still be sponsored if you go?
if you get below 12, I mean, no, like 13, 14, you only get like 50% scholarship. So you either like get paid for either your education or
Oh, okay. So that means that if you get less than 12, then they pay for both education as well as boarding school.
Yeah.
But if you get more than 12, then they'll pay for either.
Yeah.
How much is the boarding school expenses?
I don't know, but most scholars, like if they get more than 12, they would want the boarding school fees to be paid.
Versus school fees.
Yeah.
Oh my god, this is really expensive. Because school fees are not cheap for you guys now.
Because like the boarding school provides food, right? So like you need to pay for each food, each meal.
Holy shit. Okay. Is the eventual plan to stay here? And have you given any thought of that?
I don't know.
Cool. Wait, what's CCA again?
Good cards.
Is that boring?
I really know. I mean, people there are really nice. My friends said. Okay, we don't really do anything, but like you just,
I knew it.
you just get badges, like, oh, it's fine.
We just get together and
Yeah.
for like the whole CCA session, right?
Yeah.
I had this student in Girl Guides. She's actually I think you might know her, you know Gracias?
I don't know her.
Yeah.
She's my sister's. Wait, I thought she's a girl scout.
She's in Girl Scouts.
Wait, I don't know.
I can't remember. All I know is she learned like CPR.
Oh yeah, she saved the.
She saved the yeah.
But then didn't he like eventually die?
I do not know that. I thought it was like a good story, like when I say like managed to like save resuscitate enough.
I know she got into the news. Like I saw.
Yeah.
My sister told me. Her brother stays in my place.
Her brother stays in her school. Oh, her brother's like older, like a lot older, right?
He's like G2.
Ah, okay. Yeah. Gracia's supposed to join. She was my student for a while when she left. And her mom says like
Why?
maybe she doesn't
She
trust.
doesn't
Huh?
She doesn't like you?
No, maybe she doesn't trust like tuition centers in general. Or maybe she doesn't, I don't know. Because then like the reviews are not very good. Yeah, okay, let me show you some stuff. not for me, I show you all I did, but let me show you this thing that a parent sent.
Wait, we'll see your school here.
Really? Got this one?
I guess. From what I heard.
That's interesting. Okay, let's see. So, that non-useless rule. This happens when tuition centers become like mafias or fattening their pockets. I used to go there for camp, and tutors don't really care much. Yeah, I'm looking at this and I'm realizing I kept reading, and I realized, oh wait, it's so close to A, so he's talking about GC. The secondary school department generally doesn't get bad news, but I guess because as parent mom's like,
There's my sister who should sit
Yeah.
in the back.
but your sister has a punctuality problem. Like she'll come like 15 minutes late. Then like obviously because the last year the class was like 4 now really very crowded, very packed. So like there's no seats at the back, you should sit in front. Sit in front, just there.
I mean, I know she has a punctuality problem.
Yeah. But it was fun. She never got back to me on her results, which I'm like,
Oh, I think she got like B3.
well, it's okay.
Because like normally after session I would go and hang out with her, but then when I called her, she like just woke up.
She also stayed in morning school,
Yeah.
different from you.
Good for me.
But how come you all stay different?
Because in my boarding school
Just like cement.
It depends on like the distance, you know. Like which
Oh, I just want to make it a bit more
distance.
convenient for you guys.
I mean, it's not convenient for savings for pretty much.
But that's because they cannot live boarding school so close to the west, right?
Yeah.
I'm assuming.
So like, I'll just be making it like next, oh no, always going away, and I'll just wait for her to come.
Yeah. We'll wait for her to. Then it's like start like normally I start like 5 to 10 minutes late. And she's still not here. Like, where are you? Okay, now let's go for this question. Feel free to start.
Moment of boundary, so that means the pivot has to be right.
Of course.
Is the tension, is the tension 102?
What?
It's not 102.
100 to 102?
Yeah.
How do you get 102?
Cause like, is it not 2 against 1? Cause 20
You also have this. It's
or
actually,
just 200.
yeah, it's 200
So
meters.
it's 300.
No, it's not.
Why isn't it 300?
Because you have to calculate moment, not force. This guy also experiences.
Because that's super tension.
Correct. But for him to be 2 versus 1, right? This guy cannot exist.
It doesn't exist, right? That's why
He
it needs
does.
to
No,
pivot.
if he's the pivot, right, means there is no moment, correct?
Yeah.
But there is force. You are calculating 100 plus 200. All of these are forces. Do you use distance at all?
No.
So we're talking about forces, right? If I'm talking about forces, I cannot take these 2 versus him and not include him. He acts as a force. This string has force, not moment.
Okay.
Understand? So if you want to measure forces, you must consider everybody that has force. If you want to consider moment, consider everybody that has moment. Okay?
So this 0.5.
Yeah, yeah. Suppose take moment about B, by the way. This is a bit of-
Yeah.
Yeah.
So 0.58.
Nope. That's your pivot.
B.
Your pivot is B, right? How far away is A again?
2 meters.
Yeah.
So 2A
Mm-hmm.
equals. So I need to account for like all the parts that has a force.
Correct. No, all the points that have moments. I think.
So this one also.
Yeah, of course.
Times 200.
200 times 200.
0.50 times.
Why 0.50?
Why is it 0.50?
He's not your pivot here.
So
Pivot's
still
here.
count this.
No, your pivot's here.
Yeah. So
Your distance
so
is force to pivot, not just force to A.
force to pivot exactly so this and this.
Yeah. So you have force to pivot, that's why you 2 times A, right?
Yeah.
Then you have 200 times how much?
0.50.
It's not 0.50.
Oh, what?
No, it's here.
So
Okay, wait, wait.
1.5.
So okay, never mind. Let me go through this. I don't think you're getting it, which is very strange because you have done like harder questions than this before. Okay, this is your pivot, right?
Uh-huh.
You have tension at A,
Yeah.
acting 2 meters away.
Yeah.
Then your 200 newtons is acting how far away? It's here. What?
Okay.
Why would you measure this side for? Your pivot's there. This is 1.5.
1.5 times
times how much?
200
Yeah. Then your 100 newtons, eh?
plus 1 times 100.
Yes. You always measure with respect to your pivot, not just because I give you the 0.5 here. This 0.5 doesn't mean anything, right? Read the question, yeah? Okay, the question says if the tension in any of the string exceeds 220, it will break. Okay, continue.
Is the tension 100 newtons?
Yeah. Now you use your force one. Yes. Force and moment are the same thing, madam? Okay?
Yeah. Wait, if he shifts the load would like increase or decrease, or it will still stay 20 kg.
Yeah. But the D will change,
Yeah.
which means tension definitely changes.
Yeah. So string A would snap
Okay. Why would string A snap?
because the tension changes. Because it says if the tension is in any string exceeds the timing, then a string will stop.
Yeah, so how come B cannot snap?
Because we're counting it.
Wait a minute. I think you mathed it wrongly. What's 200 times 1.5?
This one is a lot.
Yeah, what is it? What's 200 times 1.5?
What do you mean?
What's the value?
Oh.
Yeah.
Okay. 300.
Correct.
Okay.
You just repeat. Miss it. Huh?
So, because the distance is shorter, so the tension. Wait, for it won't be B because like the distance is longer now. So he really have to exert as much force as A. Like you get.
I get, but the examiner will not get. Okay, so here's how we're going to answer this. Okay, so firstly, okay, tension. You can calculate it. Abigail, I hope you have calculated it as well. Okay, your tension A will be 200 newtons. Okay, you have TA times 2. Okay, is equal to damn, it's cold, man. 200 times 1.5 plus 100 times 1.0. Okay, then you calculate tension A, which means the tension at B. Tension at B, okay, you have F down, 200 and 100, and you have F up, which is TA plus TB. Okay, so your TA plus TB equals to 200 plus 100. So TB is equal to 200 plus 100. TB minus TA, which is just your 100 newtons. Okay, and what's going to happen is this person is going to shift your 20 kg this way. Yeah? When you shift your 20 kg this way, let's take a look at this diagram first. Which one is increasing? Okay, go. No, which number is going up?
The distance from B.
Which one?
1.0. Yeah.
This is weight, my friend. Your weight does not move.
Wait, the 1.5.
Yes. Okay, so as you shift, this value increases. Which means that, all other things considered, this guy has no choice but to increase. Correct or not? Okay, and of course, he's already at 200 Newton, already reaching the limit already. Still increase some more. Confirm break one up. Okay? So, string A will snap first. Okay, using principle of moments, explain your answer. Okay? So, here's how we're going to explain it very similar to the way we explained this one.
What's the principle?
This one. Principle of moments, it's in your notes. States that for an object in equilibrium, your sum of your ACW equals CW.
Oh, that one.
About the same pivot. Alright, okay, so we're going to explain that answer very similarly to this. Get it? Okay. When the weight is shifted, okay, the clockwise or anti-clockwise moment will increase. Okay, I'll write my answer silently. Okay, you just do your own and then you see. Okay? Okay, mark number 1 is there is a greater anti-clockwise moment when you shift. Right? Mark number 2 is tension A must increase to maintain equilibrium. And mark number 3 is it will increase beyond this value and it will break.
If I don't say it will increase beyond, do I not get fired?
Sorry? Okay, 2 marks out of 3.
No, 2.5.
No. It's 1 mark, 1 mark, 1 mark. Can? Good. Okay. I will not do 21 and I will not do 22. Actually, let's do 22. 21 don't need lah. 22 is more important. Because 22 is very interesting.
What do you mean?
Define. What's the definition of a moment?
Is the product
The product.
a force acting on an object and the perpendicular distance
Perpendicular distance what?
of the pivot
No.
of the object. Perpendicular distance to the force.
Is product of a force and the perpendicular distance from the line of action of the force to the pivot. Yeah. It makes so much sense after I say it, right? It's like, oh man. Okay, done. It's in your notes by the way, so you can just copy it, okay?
What?
It's on like the literal first page of your notes.
So it's just asking us to define movement?
Yeah, definition.
Oh, but then
These are 3 marks in exam.
what does about a pivot mean? About a pivot, yeah. Does that not matter?
Every moment is about pivot, yeah?
How do you calculate force?
Where's your pivot? Let's understand that first. Where will you set as your pivot? Can I give you a clue, huh? Okay, your pivot is always the point that doesn't move. During the rotation, he doesn't move. He moves, he will roll up, right? Yes. You know where your force, you know where your weight is acting, right? Yeah. Then you know where, how far away your force is acting from A.
10. Oh, 0.1.
So weight is acting 0.1. What about F?
30.
Why 30?
It's
Where's the pivot? You think you just tell me your pivots here?
Yeah.
So your force F is acting how far away?
0.2. Why not?
It's line of action. Maybe, right?
Line of action.
Pivot
Of the force.
Of the force. What does line of action of the force mean? Is this infinite line that your force acting through? Good, right? Like this, right?
Yeah.
What's this? That's what I
10.
want. Yeah. Not 0.2.
But 0.2 meters.
10 cm is 0.2 meters.
No, wait, what about this one?
What about him? This is my pivot. I'm measuring it to him.
Okay. And then,
Okay. So now you have weight is acting 0.1
F equals
equals
0.1 times 20.
Yeah.
So F is 20.
yeah.
Okay. Less than 4. How does it work?
What?
You can push the ball with less amount of force.
Yeah. Okay, the moment required to lift this fella is the constant value, right?
Yeah.
20 times 0.1 because of the weight. So if you want to minimize F, you have M equals to F times D, right? If you want to make F very small, means your distance must be
Here.
correct. Where will you exert?
B. Like here. It's not here. The pivot would be here.
No, your pivot cannot change. Your pivot stays the same.
Here.
So how to increase distance? Okay, first, let me define moment about a pivot. Moment is product of a force and the perpendicular distance between pivot and line of action of force. Line of action of force is an infinitely long line, like this. Correct?
Yeah.
So your pivot, I would set pivot as this fella here, because your pivot does not move. Pivot does not move. Okay? So using principle of moments, determine what force F is. Okay, you have weights acting down here of 20 newtons. He's acting 10 cm away. Correct? Then your force F is unknown, but he is also acting 10 cm away. Yeah?
Yes.
So you have 20 times 0.1 equals to F times 0.1. F equal to 20 newtons. The student claims you can push it with lesser force. Okay, so your moment required to push equals to 20 times 0.1, which is a fixed value of 2 Newton meter. Okay, M equals to F times D. If this guy want to decrease, this guy must increase. Where can you apply your force?
It's like on the top, like here. Is it not?
Apply the, okay, so Abigail, for reference, she's saying you apply the force like this.
No.
Oh no?
Like here. You apply.
Backwards? What the? No lah, you still have to push it up the flight of stairs. You want to bring it up.
Oh.
Okay, so let me tell you what you can do if you want to make it further. Okay, I erase all this first so it's easier to see. Instead of applying here, you can apply your force in different directions, right? You don't need to be. If you want to push it up a flight of stairs, will you push like this or will you push upwards?
Upwards.
Oh shit, right? How do I push it upwards? Can I apply a force here? I guess I can, yeah. But your perpendicular distance is 10 also, right? AKA useless.
So here.
Correct. So you will take this big guy and you apply a force here. do you see that your perpendicular distance is literally double? Yes, your perpendicular distance gets double. You are relying on the circumference. Sorry, what am I talking about? You're relying on the diameter of the circle, of the ball. Okay, so label this new force R. We have henceforth labeled it. Okay, and then R is acting 20 cm away, right?
0.0.
Right or not? You have to wait 0.1.
Yeah.
Oh, okay. So what's R? What is R? Do a quick Yeah! Oh my god, it took you like 5 years. 10 newtons is your new force. In other words, don't be stupid. You try to lift it up, don't push horizontally. It makes no sense. Can? Okay, come. Okay, I will do this question with you, okay, and then we are done. Okay? Okay. By doing with you, I mean I ask you for answers. Okay, so a child's toy consists of stiff rods hanging from cotton threads. Okay, modern animals hang by the means of these cotton threads. Okay, the rods and threads have negligible weight. So, this is a very, very important statement. Because this one.
Because the force of the weight is not acting.
Then I don't need to care about the how heavy does this guy, is he acting in the center, all this, right?
Okay.
Like there's force here also, right? Right now?
Yeah.
Okay. What conditions must be fulfilled to be equilibrium?
There's no resultant moment.
Okay. No resultant moment
And no resultant force.
exists about about the pivot or about the same pivot. And your second criteria, yes, okay, no resultant force is acting on the object. Cool?
Yeah.
Cool. Tension in T is 1.5. Okay? Do you think this tension acts up or down? Of course. Okay, so I have upward 1.5 newtons. How much does your sheep, pig, and cow weigh?
How much does my one?
Is in the question. How much do they weigh?
Sheep is 0.10.
0.10. Yes.
0.10 counts.
Okay, so where? So, in other words, do you think his weight is up or down? Downward or upward force?
Upward.
How can weight act upwards? Gravity pulls you down, doesn't it? How does you fly, right?
Downward.
Then,
Cow is 0.50.
good. So how much does your pig weigh?
0.90.
Yeah. Okay, easy. Equals to 1.5 minus 0.1 minus 0.5, which is 0.90 newtons. Answer?
0.90.
Wrong.
Oh, wait, no.
This is weight.
9 kg. This is not.
Be careful of whether you times or divide 10. Huh? W, weight equals to mass times 10. Okay, so it's the weight over 10 is 0.09 kg. If I have a 9 kg toy pig, the baby gonna die already, okay? It's not a toy fit for a child. 0 kg. 2SF, huh? Must be 2SF, huh? better, remember. Okay, the graduations on rod R are equally spaced. Weight is 0.4, elephant is 0.9. Okay, by taking moment about P. So P is your pivot. Okay, I can't spell pivot. Pivot. Okay, calculate the weight of the toy elephant. Elephant or kangaroo? Oh, kangaroo. Okay, come. How will you do this? What's the weight of the elephant?
0.90.
So this one is 0.90. Lion?
0.40.
You need this guy. How to solve? They say that the graduations are all the same. All of these is the same. How to do?
So like, consider like one of it is one, or do I have to use like a variable?
You can just use unit like X or.
Okay, so like 0.4.
Okay, wait. I write ACW equals CW first, okay? Okay, so this is your pivot.
Like
0.4. Wait, is he on the AC or CW side?
AC
Okay, so the lion has 0.4.
times 3x. Is it not?
How far away is the lion?
Oh, 4x.
Yes, times 4 units. Okay, each one is 1 unit.
Then the W plus W times U
Times 1 unit, 1 graduation.
equals to 0 and 0 times 2 units.
Good. Okay, so obviously I'm going to get rid of all my U. Okay, my U doesn't matter. So 0.4 times 4 is 1.6, right? Plus W equal to 1.8. Simple.
0.2.
Sure. Are you sure?
Yeah.
Okay. Can I write 0.2 Newton?
0.
Oh, very good lah. 0.20 newtons is the weight of the kangaroo. Easy? Correct lah. Correct. Chill. Okay? Okay. We're done for the day.
Sorry?
We're done for the day. Okay. See you, Abigail. Bye bye. Please watch the video, yeah? I will know if you haven't.